Hello friends, welcome to Learner's Planet. I welcome you to this session of D and F block elements. In this session we are going to discuss about the sulfides of transition elements, and after that we'll be discussing about the compound of chromium, that is potassium dichromate, about the method of preparation of potassium dichromate, about its properties. So let's start our discussion here. Sulfides of 3D series transition metals. Sulfides of transition metals are obtained either by direct combination of metal and sulfur, or by passing H2S, or treatment with Na2S to their aqueous salt solution. Right? So, the sulfide of iron can be obtained by simply heating iron with sulfur. Sulfide of copper. What is it? It will be cuprous sulfide or cupric sulfide. It will be cupric sulfide because the oxidation state is +2 here. This will be ferrous sulfide because the oxidation state of iron here is +2. And the higher oxidation state of iron is +3. Likewise, silver sulfide can be obtained by heating silver with sulfur again. Cobalt sulfide. This is obtained by treating cobalt chloride with hydrogen sulfide in the presence of a base. Likewise, copper sulfide, this CuS, it can also be obtained by treating the copper sulfate with this hydrogen sulfide in the presence of acid, forming this cupric sulfide and H2S. Right? This is cupric sulfide. This cupric sulfide can also be obtained by treating copper sulfate with hydrogen sulfide in the presence of acid. Right? The sulfides of transition metals are generally colored or black. Nickel sulfide, cobalt sulfide, cupric sulfide, ferrous sulfide are black in color, whereas cadmium sulfide is yellow, manganese sulfide is light pink, zinc sulfide is grayish white. Right. Sulfides of transition metals are formed in lower oxidation states, as sulfur is a poor oxidizing agent. So these sulfides, these like iron, ferric sulfide is not there, it's ferrous sulfide. So these sulfides are formed in their lower oxidation states. Why so? Because sulfur is not a very good oxidizing agent. It's a poor oxidizing agent. Say oxides and fluorides, they are formed in their higher oxidation states. Why? Because oxygen and fluorine are good oxidizing agents. Sulfides are ionic in nature but insoluble in water due to their low value of solubility product. So these are insoluble in water. These sulfides are soluble in acids like nitric acid, like H2SO4. But cobalt sulfide and nickel sulfide are soluble in aqua regia only. Cobalt sulfide and nickel sulfide are soluble in aqua regia only. Remember this. See students, now the reactions have been started, the method of preparation is started. We have to just learn it, mug it up, that's it. The method of preparation, the compounds formed, the compounds utilized. There is no way, I find no way to explain it to you. Right? You have to just learn it. Now let's see the compounds of chromium. Compound of chromium, that is potassium dichromate. Potassium dichromate, the formula is K2Cr2O7. Potassium dichromate is one of the most important compound of chromium. See, it is used as oxidizing agent. You must have studied in alkanes, alkenes and alkynes, and also you must have studied the organic chemistry part, that is phenols and aldehydes. There this potassium dichromate is used as oxidizing agent. This potassium dichromate oxidizes alcohols to aldehydes. The primary alcohol is oxidized to form aldehydes. Right? It acts as oxidizing agent in acid and as well as in alkaline medium. In acidic K2Cr2O7 is basically used. It is oxidizing agent because it gives out nascent oxygen. And secondly, in this compound, the chromium is in hexavalent state. Let's find out the oxidation state of chromium here. It is say oxidation state of potassium is +1. So it will be +2 over here, plus 2x, plus this would be -14 because the oxidation state of oxygen is -2, right? And that is equal to 0 as it is a compound. What will be the value of x over here? It would be 2x, and here -12 is equal to 0, or x is equal to +6. So this is the highest oxidation state of chromium, right? Chromium shows +3 oxidation state also, and the chromium +6 is the highest oxidation state. That is, all the electrons of 4s and 3d orbital are used in the formation of covalent bond. So chromium can take up 3 electrons and revert back to its Cr3+ state, which is a stable state over here. I have explained you this. So this potassium dichromate acts as a strong oxidizing agent. Let's see the method of preparation. Methods of preparation from potassium chromate. From potassium chromate, how it can be prepared. What is the oxidation state of chromium here? See, it will be -8. This will be +2. So it will be what? It will be +6. So the oxidation state will be 6 only. Let's see. The oxidation state of potassium is +1. So here I'll write +2, plus of x minus of 8, that is equal to 0. So x will be equal to what? +6. From this potassium chromate, potassium dichromate can be prepared. How? Potassium dichromate can be obtained by adding a calculated amount of sulfuric acid to a saturated solution of potassium chromate. So to this yellow colored solution, potassium chromate is yellow in color, and to this solution, if calculated amount of sulfuric acid is added, potassium dichromate can be obtained, which forms the orange colored crystals. Potassium dichromate crystals are obtained by concentrating the solution followed by crystallization. See, these crystals can be obtained by concentrating, and that is followed by crystallization. Let's see how else potassium dichromate can be obtained. From chromite ore. This potassium dichromate is manufactured from chromite ore. This is chromite, FeCr2O4. How this is prepared? First of all, sodium chromate is prepared. How sodium chromate can be prepared? This finely powdered chromite ore is mixed with soda ash and quicklime. So the product of that soda ash and quicklime is sodium carbonate. The mixture is then roasted in reverberatory furnace in the presence of air. Why? So that oxidation can take place. Yellow mass due to the formation of sodium chromate is obtained. See, this is chromite ore. It is first heated so that Fe2O3 and Cr2O3 are obtained. Okay. So in this Cr2O3, the oxidation state of chromium is +3. This Cr2O3 is treated with soda ash. That is the product obtained from this soda ash is sodium carbonate. And it is heated in a reverberatory furnace, that is in the presence of air, forming sodium chromate. The complete reaction, you will find there is ferric oxide, which is insoluble in water, and sodium chromate is soluble in water. Now this solution can be filtered in order to separate this ferric oxide, right? And the filtrate contains what? The sodium chromate. Now let's see how sodium chromate is converted into potassium dichromate. These reactions are very important, students. Do by heart these reactions. See, there sodium carbonate was used. Sodium hydroxide can be also used. Chromite ore, when heated with sodium hydroxide in a reverberatory furnace, the products formed would be sodium chromate and ferric oxide. Okay. Now let's see how this conversion of chromate to dichromate takes place. Sodium chromate solution obtained in the first step. This is a sodium chromate solution. See, ferric oxide is insoluble. So when the solution is filtered, ferric oxide separates out and the filtrate contains sodium chromate. Sodium chromate solution obtained in the first step is treated with concentrated sulfuric acid. When it is converted to sodium dichromate, that is the sodium chromate is treated with concentrated sulfuric acid and it is converted to sodium dichromate and sodium sulfate and water. When it is concentrated, the less soluble sodium sulfate crystallizes out. Sodium sulfate is less soluble as compared to sodium dichromate. In the presence of acid, see, chromate gets converted to dichromate in the presence of acid. Right? This is chromate is yellow in color and dichromate is orange in color. Sodium sulfate is less soluble and it crystallizes out. The filtrate is hot and is allowed to cool when sodium dichromate separates out. This filtrate is hot, say after separating sodium sulfate, it is allowed to cool when sodium dichromate separates out. But do we want to prepare sodium dichromate? No. We want to prepare or we want to manufacture potassium dichromate. Concentration of sodium dichromate to potassium dichromate. Hot concentrated solution of sodium dichromate is treated with potassium chloride. It is the calculated amount. You can't take lots of potassium chloride, forming potassium dichromate and sodium chloride. So from here we can get the potassium dichromate. It crystallizes out on cooling. So NaCl, the solubility of NaCl is more as compared to potassium dichromate. So when the solution is cool, the potassium dichromate separates out. This method is used for the manufacture of potassium dichromate. Let's see the physical properties of potassium dichromate. Potassium dichromate forms orange-red triclinic crystals and its melting point is 671 Kelvin. Remember this, that's it I can do. It melts at 699 Kelvin. Its melting point is 671 Kelvin. This potassium dichromate forms orange-red triclinic crystals. Melting point 671 Kelvin. It is stable in air near room temperature and is generally used as primary standard in volumetric analysis. You must have done titrations and all. So in titrations, this potassium dichromate is used. It is moderately soluble in cold water but fairly soluble in hot water and can be easily purified by recrystallization. It is fairly soluble in hot water. These are the chemical properties. It melts at 671 Kelvin. We have seen its melting point. But on further heating, once it has melted, on further heating, it decomposes as. Students, this reaction is very important. The decomposition of potassium dichromate. This K2Cr2O7 on heating beyond the melting point changes to potassium chromate, that is K2CrO4, and chromium oxide and oxygen. Do remember this reaction. Action of acids with H2SO4. It will form KHSO4 plus CrO3, chromium oxide, and water. On heating, a dichromate sulfuric acid mixture, oxygen gas is given out. If it's heated, say if it's simply potassium dichromate, the aqueous solution of potassium dichromate is treated with concentrated sulfuric acid. The products obtained are KHSO4, that is potassium hydrogen sulfate, the chromium oxide and water. Whereas if it is heated with concentrated sulfuric acid, that is a mixture of dichromate and sulfuric acid is heated, potassium sulfate, chromium sulfate is obtained, and the most important thing, this oxygen gas is given out, because of which it acts as oxidizing agent. With hydrochloric acid, on heating, chromic chloride is formed and Cl2 gas is liberated. So if it is heated with hydrochloric acid, this chromyl chloride is obtained. Chromic chloride, I'm sorry, it's not chromyl, it's chromic chloride is obtained and chlorine gas is liberated. Let's see how it reacts with alkalis. Action of alkalis with alkalis, say potassium dichromate with potassium hydroxide gives potassium chromate. Okay, here the color of dichromate is orange and the color of chromate is yellow. When potassium dichromate is heated with potassium hydroxide, potassium chromate is obtained and this potassium chromate is yellow in color. On acidifying, the color again changes to orange-red owing to the formation of dichromate. See, with bases, remember these equations, both of them. The decomposition of potassium dichromate and the reaction of potassium dichromate with alkali as well as acid. With alkali, it forms chromate, that is K2Cr2O4. K2Cr2O7 it should not be 4. This potassium dichromate, orange crystals, when treated with alkali, that is KOH, it forms yellow colored solution, that is of potassium chromate. But when this potassium chromate is acidified, it forms potassium dichromate. This reaction we have seen. In dichromate solution, the dichromate ions are in equilibrium with chromate ions. Do remember this, students. This is very important. In the solution, the chromate ions and the dichromate ions are in equilibrium. If the H ion concentration is increased, there will be formation of dichromate, and if the H ion concentration is decreased, there will be formation of chromate. Now let's see the oxidizing nature of potassium dichromate. In neutral or in acidic solution, potassium dichromate acts as excellent oxidizing agent. In acidic solution, I have told you, right? Say potassium permanganate, it acts as a strong oxidizing agent in alkaline, in acidic as well as in neutral. But this potassium dichromate is an excellent oxidizing agent in acidic solution. See, the reaction goes like this. Cr2O7, this takes up 6 electrons. This dichromate ion. See, in case of this, if I'm writing the oxidation states, it will be better for you. Minus 2 Cr3 plus. Right? Now, it is, what is the oxidation state of chromium over here? It's plus 6. So, it will take up 6 electrons. It is plus 3 dichromate, right? It is plus 3, plus 6, right? 2x minus 14 is equal to minus 2, or 2x is equal to 12, or x is equal to 6. And the oxidation state of chromium over here is plus 3. Now there are 2 chromium over here, so you have to put a 2 here, and it will take up 6 electrons, forming the chromium 3 plus ions. And for balancing, you have to add in hydrogen and water. So the complete reaction becomes dichromate ion plus the H plus ion plus of 6 electrons, forming the chromium 3 plus ions and water. The electrode potential is this is plus 1.31. It is the positive standard reduction potential. Positive means its tendency to lose electrons is less. It can accept electrons easily. That is why it is a strong oxidizing agent. So dichromate is a fairly strong oxidizing agent. It can take up electrons. Its tendency to reduce is not there. So dichromates are fairly strong oxidizing agents. Say ferrous salts to ferric. Obviously, ferrous salts, the oxidation state is plus 2. The oxidation state of iron is plus 2. So it can change ferrous salts to ferric salts, that is plus 3. You have to just balance it. You must have studied about the balancing of these redox reactions in your topic, that is redox reactions. So you should be knowing how to balance the equation. Write this equation, that is the potassium dichromate with H2SO4. See, when excess of H2SO4, when this dichromate in excess of H2SO4 is heated, oxygen gas is evolved. But when with calculated amount, the nascent oxygen is obtained, which oxidizes the things. See here, potassium dichromate is oxidizing ferrous salts to ferric salt. This is the balanced equation. Remember this, that's it. The equation, what you need to remember is the equation of potassium dichromate with sulfuric acid. And you can easily write the equation for ferrous sulfate to ferric sulfate. Balance it and you'll get. See, in your board exams, you're asked to write the equations, the completely balanced equation for the oxidation reactions by K2Cr2O7. In that case, you need to remember this, or do remember the ionic equation. That is Cr2O7 2 minus plus of 14H plus of 6 electrons forming twice of Cr3 plus of 7H2O. Do remember this ionic equation. Write the ionic equation for iron also. Fe2 plus to Fe3 plus it is oxidizing. So it is Fe3 plus of electrons. And then balance it. You'll get your answer. Let's see a few more oxidation reactions. This potassium dichromate oxidizes sulfides to sulfates. Sulfides SO3 to SO4. Same equation, potassium dichromate with sulfuric acid forming potassium sulfate and chromium sulfate and releasing nascent oxygen. So do remember this equation, and sulfides, the formula of sulfide, that is SO3 2 minus, to sulfate SO4 2 minus. It also oxidizes arsenides to arsenates. Arsenides formula is ASO3 3 minus and arsenates ASO4 3 minus. Halides to halogens like chloride, chloride to chlorine. The oxidation state of chloride is, it is -1 over here and it's 0. It oxidizes, say, bromide to bromine, Br2. It is -1 to 0. And iodide, that is I minus to I2. So it should be 2, 2 and 2 over here. Again, the same equation, or remember the ionic equation. And just balance the equation by the method of balancing of redox reactions. It's the same iodides to iodine. That is potassium iodide to iodine. Right? It will oxidize H2S to sulfur. H2S. The oxidation state of sulfur over here is -2 and it oxidizes it to sulfur 0. So potassium dichromate with sulfuric acid will form potassium sulfate, chromium sulfate, water and the nascent oxygen. H2S will be oxidized to water and sulfur. Right? So it oxidizes sulfides to sulfur. Sulfides to sulfates, iodides to iodine, halides to halogen, arsenides to arsenates, ferrous to ferric. See, it is an oxidizing agent, that is, it takes up electrons. So it oxidizes. Here, sulfur dioxide, it is oxidizing sulfur dioxide to sulfuric acid. That's the thing. In writing these balanced equations, you should know how to write the ionic equation and how to balance the reactions. That's it. There is nothing to mug up in this. It is an oxidizing agent, so it will change a substance or any compound with a lower oxidation state of say any element there to the higher oxidation state. Like ferrous to ferric, sulfide to sulfur, sulfite to sulfate, arsenite to arsenate. Formation of insoluble chromates. With soluble salts of lead, barium, potassium dichromate gives insoluble chromate. Say lead nitrate reacts with potassium dichromate, forming lead chromate and potassium nitrate. Here in this case, this lead chromate is insoluble and it is a very important yellow pigment. Then is the Chromyl chloride test. It is for potassium dichromate. This actually Chromyl chloride test is for HCl, for the presence of this thing. When potassium dichromate, it is not the test for hydrochloric acid, it is the test for the chlorides, chloride salts, like sodium chloride, like potassium chloride, like lead chloride, like stannous chloride. So it is a test for the presence of chloride salt. What is done here is, potassium dichromate is heated with concentrated sulfuric acid in the presence of soluble chloride salt. See, remember, the chloride salt should be soluble. It should not be insoluble. The orange-red vapors of chromyl chloride are formed. So, potassium dichromate with sodium chloride and sulfuric acid, it forms potassium hydrogen sulfate plus sodium hydrogen sulfate and chromyl chloride. Chromyl chloride is CrO2Cl2. Chromyl chloride vapors, when passed through water, give yellow colored solution containing chromic acid. So this is the test. First of all, any soluble chloride is taken, say potassium chloride, calcium chloride or magnesium chloride. These are all what? Soluble chlorides. It means they can dissolve in water, forming a solution. So that is taken and is treated with acidic potassium dichromate and heated. What is formed then is the potassium hydrogen sulfate, the sodium hydrogen sulfate and chromyl chloride. These chromyl chloride vapors, when they are passed through water, they give a yellow colored solution. Yellow colored solution of chromic acid. So we can use this test for the presence of any chloride in the mixture. If we have got a mixture in which there is chloride, we can use to detect its presence. Let's quickly sum up this. Not sum up, actually we have to find out the uses. It is used as an oxidizing agent, right, in chrome tanning. It is also used as a raw material for preparing large number of chromium compounds. And it is primary standard in volumetric analysis. These chromates and dichromates, they are in the equilibrium with each other in the solution. Chromates and dichromates are the salts of chromic acid. This chromate ion, it has got 4 oxygen atoms arranged tetrahedrally around Cr atom, whereas dichromate has CrO-Cr bond, and there are how many oxygen atoms? 7 oxygen atoms around them. In chromate ion there is CrO bond, and in dichromate ion there is CrO-Cr bond. So these are the structures of dichromate and chromate ions. So let's sum up this, students, quickly. How can we manufacture potassium dichromate? We can manufacture it from chromite ore. What is chromite ore? It is FeCr2O4. By treating this with soda ash or sodium hydroxide, you can get the sodium chromate. Then the sodium chromate is converted to dichromate in the presence of acid. Right? So chromate and dichromate, they are in equilibrium with each other. In the presence of acid, chromate can be converted to dichromate. Then the sodium dichromate is converted to potassium dichromate by treating this with any potassium salt. That is potassium chloride. It forms the orange-red colored crystals. Its melting point is 671 Kelvin. On decomposition, it forms potassium chromate and chromic oxide. With acids, it gives out oxygen gas or the nascent oxygen, that is with sulfuric acid. With HCl, it forms chromic chloride, and it has got oxidizing nature. It is a strong oxidizing agent. It oxidizes ferrous to ferric, sulfides to sulfates, arsenites to arsenates, halides to halogens, iodides to iodine, hydrogen sulfide, there are sulfides to sulfur, right? So this is how the reactions of potassium dichromate are there. And remember, in your exams, you're asked to write the balanced equation for any of the oxidation reactions carried out by potassium dichromate, right? So these are the reaction, students. For you don't need to mug up the oxidation reactions. Do remember the reaction of potassium dichromate with sulfuric acid. That's it. And if you know the oxidation states, you can easily write the other equations. And just balance it according to the the rules for balancing a redox reaction. So this is all about this session, students. In the next session, we'll be discussing about the compound of manganese, that is potassium permanganate. Thank you, students, for listening patiently. Just go through the reactions so that you can just remember it. Listen this session and go through the reactions. Thank you and do have a nice time ahead.